All right, so trapezoid today. Trapezoid rule. Now, we're talking about approximating the area under the curve. So the definite integral, that's the infinite Riemann sum. That's going to give you the actual, okay? But there are times when you don't have a curve. You don't have an equation for a curve. Say you're dealing with statistical values, things like that, and you're trying to come up with something, charts, other things, without actually having a curve. Well, then you want to try the best way to approximate it. Well, the best way of rectangles would be do more rectangles. Right? Trapezoids on a finite number can actually give you a better approximation of the area under the curve. So here's why. Okay? Let's say we have a curve here, just some generic curve. And if I'm going to produce rectangles like we've seen with the Riemann sum, let's say I do a couple of rectangles there. I'm either going to come from the right and have more, or I'll come from the left and have less. Everybody agree? Probably about the same either way. I don't know which one's going to be more accurate, above or below from the right or from the left, without actually calculating something. But I'm definitely going to have extra here, or like I said, if I came from the left, I don't have quite enough. But it's still an approximation. Okay? Trapezoids, on the other hand, trapezoid will give us a little bit better approximation because the trapezoid is angled at the top. Now, we're used to a lot of times seeing a trapezoid back in some basic geometry where we have both sides kind of angled like that. That would be a trapezoid. Sometimes we see it with a right angle. The key is you had two sides that were parallel. And what we're basically doing is just turning this up on its end. So I have the angle piece up at the top. Okay? So that quick, crude drawing shows you right there that you're going to get a better approximation generally with a trapezoid rule. Okay? Now, you can make a case for Riemann a lot of times if you use the midpoint. That might be pretty close to the same there. Not really sure. Again, without numbers, it's hard to tell, but you're still kind of looking at space that you're missing or have too much of, things like that. So this is just another way of making that approximation for a finite number. Infinite, still infinite Riemann is going to be that definite integral. So we're talking about approximations. Now this strange looking formula over here. This is your trapezoid formula. So let's kind of think here from our past. The area of a trapezoid, 1/2 h b1 plus b2. That's how we find just the basic area of a trapezoid. And I'm just going to redraw this one a little bit bigger. So your bases are the parallel pieces. It doesn't matter which one's b1, which one's b2. They were the two bases. Okay. Your height's over here on the end, how tall it was. If you had it angling two ways like I had in the previous one, then you could draw the height off of here. That's the same height. Okay, it's not going to matter. Right? That would still be the height of this trapezoid. And if we had all those values, you could find the area. Well, now let's flip it up on its end. If I flip it up on its end, this right here becomes the h. That becomes the height. This becomes b1, b2, standing up on its end. Is everybody okay with that? So if I calculate this area, 1/2, height, sum of the bases. Now let's put this in terms of being in an xy plane. In an xy plane, this would be delta x. If you're along the x-axis, right? That's my change in x. Delta x is dx. Delta x is also b minus a over n. for that piece. And I knew I left something out. Left my 2 out there. Put a 2 in there. Sorry about that. So this is B minus A over N. I left my 2. You know where the 2 came from, right? The half in front. So it really looks like this. I just forgot to put the 2 in when I put the formula up here for you. It really looks like that. I just put the 2 on the bottom. Okay. So this is my delta x, B minus A over N. And then here's my sum of my bases. Now let's kind of investigate this. This would be the same height here. Okay? This would not be the same base, though. That'd be base 3. Everybody agree with that? Mm-hmm. But if you were going to find the area of these 2 trapezoids and then add them together, you're going to use that inner base twice. One for the left one, one for the right one. Does that make sense?
Yes.
Okay, so if I write out the formula here, maybe it looks something like this. 1/2 height, B1 plus B2, that's our first one, plus 1/2 height, B2 plus B3. Does that look correct if I'm going to just add those 2 up? I don't have numbers, but I got variables sitting in there. Now let's look. This is what we call a common factor here. Same thing in each one. So if I factor that out, I'm going to have 1/2 height, B1 plus B2 plus B2 plus B3. That would be what's left. I'd have, coming out, I've got these 2 left, plus then these 2. Well, I can actually combine the inside to 2B2. And that's where all these 2's come from. So whatever's interior is going to get used twice because it's used for its current trapezoid and then the one next to it. That's what's happening. Any one of these interior ones is going to be used twice. So if I had another one over here called B sub 4, still the same height, that would change this formula now to 1/2 height, B1 plus 2B2 plus 2B3 plus B4. Because now I'm having to use these 2 inside ones twice for 2 different trapezoids. So again, that's where all these 2's are coming from. Remember the f values? F of whatever was talking about the function value, the height. Okay. So if this was x sub 0, that's f of x sub 0, just like we saw back with the rectangles. Our function value is that y coordinate. So we're using the first one time. Then anything interior is going to be used twice, 2 different trapezoids. And then the last one on the end, whatever it is, in this case it's B sub 4, gets used once. So it definitely looks a little strange, but if you kind of visualize how these are being used twice, it makes sense where those 2's are coming from. This guy out here isn't any different than we saw with the rectangles. The only thing different is the half. But there's a half in the trapezoid formula. That's where the half's coming from. Okay. And there's my height. Are you okay with that idea? Okay, now let's look at a particular problem here. Let's get a curve. Let's use the trapezoid. And let's go, let's say -1 to 2 of x squared dx. And we're going to evaluate this integral using a trapezoid rule. Okay, I know we can do the definite integral here and what have you, but let's use the trapezoid rule. How many trapezoids you want?
16.
16?
No,
Okay.
3.
Oh, 3 works too.
Sure you want 3?
I want 64.
No.
2 or 4.
I'll go 3. 3 was said first. I don't want to do 16. I'll let you do the 16 one next. Okay. And if it's wrong, you get no credit for the day. Well, 16.
I got you. Don't even worry. I got you.
All right, so first off, think back to how we did the rectangles. Remember how we looked at the number line, trying to decide, hey, what the width's going to be, where each point would be? Do the same idea. B minus A over N. Okay, so that would give me my height, my H, my delta X, that width down there at the bottom of the trapezoid. Well, here you would have 2 minus negative 1 over 3, which would be 1, right?
Yes.
Okay, so now let's think of the number line. We're going to start at negative 1. Then we're going by 1, so we'd have 0, 1, 2, quit there. So my trapezoids are coming up here above. Okay. So I'd have 1, 2, 3 trapezoids there. Everybody okay with that?
Yes.
Now, as far as writing it out, 1/2. I know it has B minus A over 2N, but it's really that half in front, times my height, all right, height, base, width, however you want to think of it, but it's this part right here. Remember, they're standing up on their end, times F of negative 1 plus 2F of 0 plus 2F of 1 plus F of 2. There's my write-up. So notice the inside ones are being used twice. The 0 and the 1. Okay, so that's where we were going over before. These insides are being used twice because they're part of 2 different trapezoids. Now we're just evaluating. 1/2 times 1 is just 1/2. So let's see. Negative 1 squared is 1. Plus 2 times 0. Plus 2 times 1. Plus 4. So remember, x squared is my function. And what's that? 8, 9 halves?
7 halves.
7 halves? Oh, that's 8.
7.
6, 7 halves. Yeah, 7 halves. So 3.5?
Yep.
Something like that. Everybody okay there? So let's go with, all right, how many trapezoids do we want this time?
What are the numbers?
4.
What are the numbers first?
Doesn't matter.
4.
4?
Yes.
Okay. So from 2 to 4. And we'll go n equals 4 this time. And kind of like the rectangle, you can do 20, 25, 30 trapezoids, but you're not going to be asked for that many. Because if you could do 4 or 6 of them, you could do 30 of them, right? It's going to take more work. Right? So let's say 4. Well, the first thing we need to figure out is what the spacing is. So B minus A over N. 4 minus 2 over 4. Go half. You agree with that? You want fractions or decimals?
Fractions.
Fractions, okay. So we start at 2. Right. And if I start at 2, what we do with the rectangles, I say go ahead and write that in your common denominator, which would be a half. So 4 halves. Because then you're just adding a half each time. I know 4 halves is 2, and that's fine. But especially if you get some oddball fractions, like maybe an 1/8 or something, it kind of helps you. Because now you'd have 5 halves, 6 halves, 7 halves, 8 halves. And there's my 1, 2, 3, 4. 8 halves is 4. I reached it. And again, like I said before, nothing wrong with keeping this 2. That's 3. And that's 4. But a lot of times if you go to whatever your common is, then you're just adding to the numerators. Okay, helps you with your spacing. So now my write-up, 1/2 times 1/2. There's my B minus A over N. Times f of 2, I just wrote 4 halves as 2, plus 2 f of 5 halves, plus 2 f of 3, plus 2 f of 7 halves, plus f of 4. Does everybody agree with that? So now's when I care about this guy. It says I haven't looked at that x cubed plus 1 yet. It really doesn't matter to me. I'm trying to get my intervals split up. So I'm looking back at my number line piece like I did before. I've got my b minus a over n, so I've got the width or base or whatever you want to say of each trapezoid. And now I'm going to line it up in my trapezoid formula. So not too bad based on how bad this looks to start with. Okay. Some of the same stuff we've done. As far as the values go here, let's see, I'd have a 1/4 out in front. F of 2, 8 plus 1 is 9, plus f of 5 halves, it's 125 eighths, plus 1, plus 2, f of 3, 28, plus 2, 7 halves, 7 cubed, 343? Is that right? 343? 8 plus 1. And 4 would be 64, 65. So definitely kind of a pain because of the fractions, but still you have a calculator, pretty basic on getting the values out there. It's not a big deal. Okay? We can go back and get all of those values. What we want to be sure of is we get these guys first so that we can split this up equitably. I don't care if it's a fraction or not. Doesn't matter. I've got my half out in front. Then my b minus a over n. And then in comes the function value. So these would be the heights of each one of the trapezoids. So the left height plus the right height. So it's going to be 1 and then 2 of the interiors, the one on the end. 1, 2 of each of the interiors, the one on the end. Going through. Everybody okay there? Did anybody get an answer for this one?
47 and 3/4.
47 and 3/4?
I got 60.75.
50.75?
60.75.
60.75.
Whoops.
I may have screwed up on my.
Anybody validate one of those?
I didn't really feel
You didn't really feel like doing it.
Check it for me,
Alright.
please. I got a number right.
I have to do the high one.
You already got to do 16 on it, right?
Oh, I know.
16.
Yeah.
62.75.
Is it 62.75?
That's what we got.
Because it's 50.
I don't know. 65. Let's see.
This is
9 and 56 is what? 65, right? 65 is 130.
Dang it.
What?
You're gonna be wrong, but I don't
She got it.
I don't know.
You just typed it in wrong.
Just plug
I was
everything.
thinking
125 fourths
I
plus
did
2.
too.
343 fourths plus 2.
Did you put?
Wait, why is it?
Why did you say we did the 2?
You got it.
Oh, you're restricting the 2. Okay, that's what I was gonna
I'm trying to make it a little easier for myself. So 1/4, that'd be 134 plus 468.
We're doing it great.
Determined.
Does that look right?
Yeah.
Hey, that actually reduces. So 117. So 1/4 times 134 plus 117. That's 247, 251.
Oh, it is 62.7. There we go.
You're right.
Where did I go wrong though? That's where I'm confused.
You typed the number in wrong.